Hello friends, welcome to my channel. Myself Parag Jambulkar. In this video, we will discuss about Superscalar architecture. The processor which follows Superscalar architecture are also called as Superscalar processor. But before starting Superscalar architecture, we should know about scalar architecture, vector architecture, pipeline architecture. So what do you mean by scalar architecture? Again, the processor which follows scalar architecture are called as a scalar processor. In the same way, we can say about vector processor. Now, scalar architecture means the processor which operates about scalar quantities or scalar data items. For example, addition of two numbers, multiplication of two numbers, likewise. So those are called as scalar architecture or scalar processor. While vector processors, they operate on array of data. So that is the difference between scalar architecture and vector architecture. Now there is one more term called as the pipeline architecture. So scalar processors, they follow pipeline architecture. Pipeline architecture in the sense the instructions are executed in terms of stages. So for example, fetch, decode, execute and write back. So in the first cycle, one instruction is passed, it will follow the fetch stage, then it will be in the decode stage, then it will be in execute stage, and then it will be write back stage. One first instruction has completed fetch stage, so another instruction can come and it will be in a fetch stage. While at the same time, first instruction will be in a decode stage. Likewise. So this is called as pipeline architecture. Now we will have term called as superscalar architecture. Now see, compare superscalar architecture and scalar architecture. One name is common, that is the scalar architecture. Now see, we say fast and super fast. So what do you mean by super fast? It is better than fast. That's why we call it as super fast. In the same way, superscalar in the sense it is a processor which has a better performance than the scalar architecture or scalar processor. That's why it is called as a superscalar processor. Scalar processor execute single instruction at a time, while superscalar processors they execute multiple instruction at a time or per clock cycle. Now for each instruction required one pipeline. So as superscalar processors they execute multiple instructions per clock cycle, they require multiple pipelines. Now superscalar processors they follow instruction level parallelism. In the sense, multiple instructions are executed or implemented parallelly. Now what kind of instructions? Instruction can be of type load, they can be of type store, or they can be arithmetic instructions. Arithmetic instruction in the sense for addition, multiplication, likewise. Now superscalar processors are the single processors. So here we are not talking about multi-core architecture. If it is, then it is a single core. So superscalar processors are the single processors. They are not the multi-core. If it is a multi-core, then it is one core. We are talking about the one core. Superscalar processors are of type RISC processor. In the sense, reduced instruction set processor. When multiple instructions are executed parallelly, these instructions should be independent. Independent in the sense, there should not be any dependency between the instructions. So dependency can be for data or for resource. So when multiple instructions are executed parallelly by using a superscalar processor, so there should not be any data dependency or resource dependency. If there is any dependency, so that unnecessary dependency can be eliminated by using additional registers. Now we will see how scalar processor work and how superscalar processor work. Same 4 instruction we will give to the scalar processor and same 4 instruction we will give to the superscalar processor. As we have told earlier, so only one instruction can be passed in one clock cycle. So see, when we are passing first instruction, so this is a one clock cycle. As we are using a pipeline architecture, so there will be various phases, various stages. So fetch, decode, execute and write back. Now when first instruction is passed, so it will be in a fetch stage. When second instruction will come, so first instruction has completed fetch stage, so it will start from the fetch stage. At the same time, first instruction will be in a decode stage. Likewise, when third instruction will come, it will start from the fetch stage. At the same time, second instruction will be in a decode stage, while the first instruction will be in a execute stage. Likewise, so for completing 4 instruction, we require 7 clock periods. Now we will talk about the superscalar architecture. So assume we are using 2 pipelines. So at the same time, in a 1 clock cycle, we can pass 2 instructions. So 2 instructions will be in a fetch stage. Now after 1 clock period, these 2 instructions will be in a decode phase. So after that, we can pass another 2 instructions. So when these 2 instructions will be in a fetch stage, at the same time, this first 2 instructions will be in a decode phase. Now in the same way it will follow. So for completing 4 instructions, it requires only 5 clock periods. While if you use scalar processors, for completing same 4 instructions, we require 7 clock periods. But understand that here we have used 2 pipelines. Similarly, you can use multiple pipelines. So advantage of having superscalar processor is speed up the process. So for 4 instructions, 7 clock periods, while for the same 4 instructions, we require just 5 clock periods. Now we will discuss about advantages of superscalar processor and limitations of superscalar processor. So in last example, as you have seen, more instructions are executed per clock cycle in superscalar architecture or processor, which speed up the processing. So suppose one task has 4 instructions, and same task if you give to the scalar processor and same task if you give to the superscalar processor, so definitely superscalar processor will finish it before. And hence, because of that, we get higher throughput in superscalar architecture. Throughput in the sense final output. Now we will talk about limitations of superscalar architecture. One thing that affect on the performance of superscalar architecture or superscalar processor is the dependency between the instructions. If instructions have more dependency, so dependency can be of 2 types. It can be dependency for data or dependency can be resources. If instructions have more dependencies, then it will limit the performance of superscalar architecture. We have to handle the dependencies properly. If you do not handle the dependencies properly, so you cannot execute more instructions per clock cycle. And to handle these dependencies properly, we have to use compiler based optimization, and also we have to use some hardware techniques. So friends, I hope you like this video. If yes, then click on like, subscribe to the channel, and don't forget to press bell icon so that you will get notifications of my next video. So stay connected. Thank you.